clearest pictures yet of Neptune, the most distant planet in our solar system. Take a look. The striking infrared images were taken this summer by the James Webb Space Telescope. The James Webb Space Telescope has recently trained its mirrors on the distant world of Neptune, and what it captured is nothing short of staggering. In an observation that has shaken the field of planetary science, Webb recorded the unmistakable signature of a massive object colliding with the ice giant. The raw power and scale of such an event seen across the void by one of humanity's most sophisticated instruments highlights the fragile, dynamic, and violent reality of our solar system. For the first time, scientists and observers alike were able to watch in real time as something enormous from the depths of interplanetary space slammed into Neptune's atmosphere. A sight that bridges the line between the unimaginable and the undeniable. Before we start, smash the like and subscribe button for more updates. Neptune, often described as a blue jewel on the edge of our solar system, has long carried an aura of mystery. Its storms, its icy winds traveling faster than the speed of sound, and its distant location have made it a place of speculation and curiosity. Webb's infrared eyes, designed to pierce through veils of dust and atmosphere, allowed a clear recording of what happened. A massive object, dark and cold in the void, hurtled toward the planet and disappeared into its cloudy, turbulent skies. The energy released during the impact manifested as sudden bursts of heat, rippling shock waves in the upper atmosphere, and luminous streaks that briefly illuminated Neptune's shadowed regions. The very act of witnessing such an impact shifts the understanding of Neptune from a quiet, lonely outpost of the solar system into an active participant in ongoing cosmic drama. This event suggests that collisions of this magnitude are not confined to the early chaotic years of planetary formation, but remain a part of solar system evolution. Even now, Webb has shown with breathtaking clarity that the giant worlds on the outer rim are still targets of wandering bodies, remnants from the creation of the planets themselves. The implications for planetary science are vast. First, the details of the collision provide a real-world experiment into how Neptune's atmosphere responds to sudden injections of energy and mass. The layers of methane, hydrogen, and helium that compose its clouds are known to be dynamic, but until now, scientists had only computer models to simulate how a colossal impact might disrupt them. Webb's instruments tuned to infrared light captured the heat signatures and evolving cloud structures as they unfolded. Watching the disturbance spread through the atmosphere offers a first direct evidence of how Neptune absorbs, distributes, and eventually dissipates sudden cosmic assaults. There is also the question of what exactly the impacting object was. Webb's sensitivity allowed scientists to trace its approach, suggesting it was not a comet glowing with sublimating ice, but rather a large dark body, perhaps a fragment of a Kuiper Belt object or even a rogue asteroid dislodged from the outer solar system. Its sheer size ensured that it did not burn up harmlessly in the upper atmosphere, but penetrated deep, unleashing energy equivalent to countless nuclear detonations. The brilliance of this event is that it gives humanity a front-row seat to watch planetary defense play out in a natural laboratory far removed from Earth. When astronomers dissect the images, they are not simply marveling at cosmic spectacle. They are also extrapolating what such an event would mean closer to home. Earth, though shielded to some degree by Jupiter's gravity and its sweeping orbital path, remains vulnerable to wandering objects. The Webb images of Neptune's impact provide a framework for modeling what might happen should a similar object collide with Earth, Mars, or another habitable candidate beyond our solar system. Neptune has become a test subject, not by choice, but by fate, and its sacrifice expands humanity's protective foresight. The drama of the impact also reawakens curiosity about Neptune itself. Unlike Saturn or Jupiter, Neptune has been visited by spacecraft only once when Voyager 2 swept past in 1989. That flyby provided the first close-up images of its dark storms, its rings, and its faint but active moon system. For decades since, Neptune has remained a world viewed from afar. Now, thanks to Webb's gaze, the planet has erupted onto center stage once again, forcing scientists to reconsider it not as a frozen, inert giant, but as a world susceptible to sudden, violent transformation. The scale of the collision makes one imagine what it might have looked like to an observer nearby. The immense streak of fire and plasma, spreading shock waves across the planet's already tumultuous weather systems, would have been a sight of overwhelming violence. Neptune's winds, some of the fastest in the solar system, would have caught the ejector and driven it into titanic storms, amplifying turbulence across latitudes. The normally steady cold blue glow of the planet briefly transformed into a place of radiant energy with infrared and visible light emissions spiking in ways that Webb could carefully catalog. The importance of Webb's role cannot be overstated. Designed not specifically for planetary impacts, but for studying the early universe, galaxies, and the formation of stars, Webb has shown its adaptability. Its instruments, tuned to detect faint whispers of light billions of years old, are just as capable of analyzing the sudden thermal bloom of a cosmic collision. That versatility underlines why the telescope has been hailed as humanity's most ambitious eye on the cosmos. By capturing this collision, Webb has expanded its legacy beyond distant galaxies to the volatile reality of our own planetary neighborhood. Another implication lies in the realm of planetary geology and chemistry. If the impacting object carried a unique composition, its materials would now be mixed into Neptune's atmosphere and possibly even its deeper layers. Tracking these chemical signatures in the weeks and months ahead will reveal how alien material alters the chemistry of giant planets. Scientists can watch to see if heavier elements settle into the planet's interior or if they disperse widely across the atmosphere, subtly changing Neptune's color, density, or cloud structure. It is like adding a drop of dye to a vast ocean and waiting to see how currents carry it. The discovery also breathes new life into the study of Neptune's moons. These small bodies, particularly Triton, could have felt the aftershocks of the collision. While Webb focused on the planet itself, the gravitational reverberations might extend outward, stirring dust in the ring system or triggering subtle shifts in moon orbits. If smaller impacts occur regularly, they might even play a role in shaping Neptune's rings and satellites over time. Such dynamics have long been suspected, but Webb's observation of this colossal event provides a kind of catalyst that encourages further exploration. Beyond the purely scientific dimensions, the spectacle invites reflection on cosmic perspective. From Earth's vantage point, the idea of a massive object striking a distant world can seem detached and abstract. Yet, seeing the energy release, the flashes, and the transformation unfold on a planet more than 4 billion kilometers away makes the cosmos feel startlingly alive. It reminds humanity that planets, no matter how distant, are not static ornaments, but participants in a universe of constant motion, chaos, and transformation. The data streaming back from Webb are not just images. They are stories written in heat, light, and chemistry. The evolving shock waves across Neptune's atmosphere tell a story of violent interaction. The fading glow of the impact's thermal bloom marks the resilience of planetary systems to absorb and heal from such blows. Every pixel of data contains lessons about survival change and the relentless forces of cosmic mechanics. For astronomers who have longed their eyes about outer solar system dynamics, the collision is a treasure chest. Models can now be calibrated with real evidence. The density of the impactor, the speed at which Neptune's wind disperses the energy, and the time it takes for the atmosphere to return to equilibrium are all metrics that can be applied to countless other scenarios. From exoplanet atmospheres to the early days of Earth, when impacts help shape its destiny. The excitement surrounding the event also extends to the public imagination. People are drawn not just to the science, but to the spectacle. The thought of a massive unseen traveler from the cold void plunging into Neptune fires the imagination about what other dramas unfold unseen in the dark. Every collision witnessed becomes a reminder that the cosmos is not merely a backdrop but a stage of endless performance. Neptune has for this moment played the lead role in a play of titanic scale, and Webb has delivered the front row seat. As scientists pore over the data, new questions are already rising. How often do such collisions occur? Is Neptune uniquely vulnerable because of its position at the edge of the Kuiper belt where icy bodies drift? Or do Jupiter and Saturn shield the inner planets by attracting and absorbing far more impacts than we realize? Webb's discovery may prompt a new era of vigilance, not just in watching Neptune, but in scanning the entire solar system for signs of such titanic encounters. There is also the philosophical resonance of watching a planet endure such violence. Unlike Earth, Neptune hosts no life, no civilizations, no observers save for the distant gaze of human instruments. And yet, its collision reminds us that the forces shaping the outer solar system are not unlike those that once shaped Earth. Impacts delivered water, organics, and heavy elements to our young world. Watching Neptune now is like looking back in time at a crucible that forged habitable worlds. The event underscores the deep interconnectedness of planetary science. By understanding Neptune's collision, scientists draw lessons about Earth, Mars, and countless exoplanets orbiting distant stars. The universe has handed humanity a live experiment, and through Webb's eyes, the data become universal, extending far beyond one distant gas giant. The magnitude of this discovery also invites speculation about future missions. Neptune, long overlooked in favor of Mars and the Moon, may now climb high on the list of priorities for exploration. A dedicated probe sent to orbit or fly by Neptune could build on Webb's revelations, offering continuous monitoring of its weather, atmosphere, and impact history. If humanity is to understand the solar system's dynamics, the outer giants cannot be left as mere afterthoughts. Webb has reminded us that Neptune is not a static world, but an active laboratory. From a storytelling perspective, the site of a collision on Neptune, captured by Webb, brings ancient myth and modern science. The Romans named the planet after the god of the sea, a fitting title for a world of storms and deep swirling mysteries. To witness it struck by a massive object evokes imagery of storms upon oceans, of titanic forces wrestling in the deep. And yet what once belonged to myth is now etched into scientific record with instruments of silicon, glass, and gold recording the reality. As the glow of the collision fades into Neptune's clouds and the planet resumes its familiar serenity, Webb continues to gaze outward, ready for the next surprise. But for those who have studied the cosmos, this moment is unforgettable. It marks not just a